student, welcome to all of you. Next physics lecture. Myself Rajesh Lagan, physics teacher. Now we are to see the next chapter number 3, kinetic theory of the gases and the radiation. This is the video number 24. In that chapter, kinetic theory of gases and the radiation, there are a lot of points. Introduction, pressure of the ideal gas, root mean square velocity, then interpretation of temperature, specific heat capacity, then in radiation, absorption, reflection, transmission of the heat radiation, then perfectly black body, then emission of heat radiation, Kirchhoff's law, then spectral distribution of the black body, and last one is the Stephens Boltzmann's law of radiation. In that chapter, there are the 3-4 points which can be the reduced. That points are behavior of the gas, ideal gas and real gas, mean free path, and the law of equipartition of energy. These points are reduced according to the board syllabus. These points which are reduced in that chapter. And now we have to start here some introduction about this kinetic theory of the gases. This solid, liquid, and gas, which are the three different states of the matter: solid, liquid, and gases. Solid is nothing but the strong interatomic forces. Liquids, weak interatomic forces, and in gases there is no interatomic forces. Solid has definite shape, liquid has no shape, but it has the volume, and gases do not have the definite shape and the volume. Then there are the three gas laws. We have to see here the three gas laws, and from this we have to find the ideal gas equation. PV is equal to nRT, and which is very important for your basic concept in that physics. We have to clear that this ideal gas equation, that is the PV is equal to nRT. How that ideal gas equation we have to prove here? For that purpose, we have to consider here the three gases laws, and these laws are: first one is the Boyle's law, second one is the Charles law, and third one is the Gay-Lussac law. This is the very basic. You have to also learn in 11th standard, but you have to well known about these three laws. First law, Boyle's law: at constant temperature, the pressure of given mass of gas is inversely proportional to its volume. At constant temperature, the pressure of the given mass of gas is inversely proportional to its volume. That is, you have to write here, P is inversely proportional to V. This is the Boyle's law. You have to understand this. The temperature should be remains constant. Then there is a relation between the pressure and volume, and this pressure of the given mass of gas is inversely proportional to its volume. Okay. Then next one is the Charles law. What is the Charles law? At constant pressure, the volume of the given mass of gas is directly proportional to its absolute temperature. In this Charles law, first we have to remember pressure is a constant, and then there is a relation between the volume and temperature. The volume of the given mass of gas is directly proportional to its absolute temperature, and so that we can write here V is directly proportional to T, where T is the absolute temperature. Now third one is the Gay-Lussac law. In this law, the volume must be constant. Therefore, at constant volume, the pressure of the given mass of gas is directly proportional to its absolute temperature. In Charles law, volume is directly proportional to temperature, and in Gay-Lussac law, the pressure is directly proportional to its absolute temperature. Therefore, we can write here the P is directly proportional to T. T is the absolute temperature. If you have to understand these three laws, then from these laws we can derive the ideal gas equation. And this is very important. You can use this ideal gas equation in various purposes. Now, to prove this ideal gas equation, we have to consider here, let P, V and T be the pressure, volume and absolute temperature of the n mole of the gas. We have to consider here the pressure, volume and temperature. P, V, T be the pressure, volume and absolute temperature of the n mole of the gas. Then by the gas laws, first of all, this Boyle's law, we have to see here, this volume of the given mass of gas is inversely proportional to its pressure. Suppose this is the V is inversely proportional to P. This is the equation number 1. Now, from the Charles law, we have to see here, at constant pressure, volume of the given mass of gas is directly proportional to its temperature. Therefore, from the Charles law, we can write V is directly proportional to T, and this is the equation number 2. Okay. Then you have to see that this equation number 1 and 2, LHS is VV. Boyle's law, inversely proportional to P. In Charles law, V is directly proportional to T. LHS is same, therefore we can compare this from 1 and 2. V is directly proportional to T upon P, because T is directly proportional and V is inversely proportional, so that V is directly proportional to T, this is the numerator term, and this is the denominator term. Therefore T upon P, V is directly proportional to T upon P. Remove this proportionality sign, then take this P here. PV is directly proportional to simply T, and removing this proportionality sign, PV is equal to RT, and this R is the universal gas constant, and we can write here PV is equal to RT. If you have to take the n number of mole of gas, then we can write here PV is equal to nRT, where n is the number of gas molecules, R is the universal gas constant, and this PV is equal to nRT is nothing but the ideal gas equation, which is the very important. You can use this in various basic concept. You have to remember this ideal gas equation, PV is equal to nRT. Now there are the two terms. Which one is what is meant by the absolute temperature? You also known about this absolute temperature. What is the Avogadro's numbers? What is meant by the mole? Absolute temperature means what? The temperature at which the pressure of the gas would be 0 is minus 273.15 degrees Celsius, which is termed as absolute zero temperature. Sometimes you have to ask this, what is the absolute temperature, absolute zero temperature? Then you are unknown about this, what is meant by the absolute zero temperature. You know about this. The absolute zero temperature means what? The pressure of the gas, the temperature at which the pressure of the gas at will be the zero, but which is at the minus 273.15 degrees Celsius, and this is nothing but the absolute temperature. Also there should be one term, the Avogadro's numbers. This is the constant term having the value 6.03023 into 10 raised to 23. This is the a number of particles of the atoms or the molecules. This Avogadro's number, that is the number of particles, that is the atom or molecules in 22.4 liter of any gas, and which is termed as the Avogadro's number, and which is approximately equal to 6.023 into 10 raised to 23. Also, what is meant by the mole? Then 1 mole is the amount of substance that contains the as many entities or the particles, and which is also the 6.0221 into 10 raised to 23 molecules in 1 mole. This amount of molecules are contained. So this is about the This basic concept in this kinetic theory of the gases, we have to see here there are the different states of matter: solid, liquid, and gases. We have to distinguish this solid, liquid, and gases also. Then we have to state here the three gases laws: Boyle's law, Charles' law, Gibbs-Zach law. From these laws, we can derive the ideal gas equation PV is equal to nRT. We also known about this: what is the 1 mole of the gas, what is the absolute zero temperature, what is the Avogadro's number, what is the value of this, you know this well. Now we have to see in this the really the what is the kinetic theory of the gases, what are the features about this kinetic theory of the gases. Just you have to remember in that kinetic theory the what is the assumptions of this kinetic theory of the gases. You know this, then you can just clear your next point which can be explained in that chapter. In that chapter there are the one lengthy expressions, that is the derive the expression for the pressure of the given mass of gas P is equal to 1/3 rho c square, and this is very important. For that purpose we have to see that there are some features about the kinetic theory of the gases we are known about this. First of all, the gas is the consist of the large number of extremely small molecules. This gas is nothing but it is the large number of extremely small molecules, and these molecules are rigid and perfectly elastic. These molecules which are always rigid and perfectly elastic. Also, all the gas molecules of same gas are identical. All the molecules of same gas are always identical. Actual volume occupied by the molecules is very small as compared to the total volume of the gas. The intermolecular forces of attraction between the gas molecules are negligible. There is no intermolecular forces of attraction in between these gas molecules, so that they are moves randomly here and there, or they are collide on the walls of the container. They have to randomly move here and there. Also, the molecules are always in a state of random motion, and due to this random motion, the molecules collide with each other and with the walls of container, and this collision is also perfectly elastic. Then this between two successive collision between the gas molecules, the travels along with the straight line, and its velocity should be the constant. Average number of the gas molecules per unit volume, it should be remains constant. And last one, the average kinetic energy is directly proportional to its absolute temperature. These points you are also known, because we have to see in the next point the derivation for the pressure of the given mass of gas on the basis of the kinetic theory. Then we have to explain how the gas can be the randomly move, which can be the collide on the walls of the container, rebound with the same velocity, its direction is opposite. Then what is the momentum, initial momentum, final momentum, and from this we can use the mean velocity, mean square velocity, and the RMS, that is the root mean square velocity. And by using this we can derive this pressure of the given mass of gas on the basis of the kinetic theory, that is nothing but the P is equal to 1/3 rho, that is the Nm upon V c square. And for that purpose we have to see these features of the ideal gas equation, which are very very important. Now with this, see in the next lecture the expression for the pressure of the given mass of gas. If I have to understand this well, now I have to stop here. Okay, thank you.